Welcome to Algebra, Inequalities Revisited. We discussed solving inequalities in an earlier lesson, and now we return to that idea, examining more and more complex inequalities, requiring more steps to solve. Reviewing one of the slides we examined in the previous lesson on inequalities, we remember that dividing by a negative value, as you can see in the second and fourth examples, requires that you flip the operator for the final result. In the second example, dividing by -2 flips the operator from greater than to less than in the final answer. In the fourth example, dividing by -4 flips the operator from less than or equal to becoming greater than or equal to. Also, the variable in the final answer for an inequality needs to be listed on the left. And so, if it ends up on the right after the process is completed, it is important to flip the entire inequality, as you can see in the third and fourth examples on this slide. For the number line graphs, remember that an open circle is used when the operator does not have an equal, and a closed circle if it does. Before moving on, pause the video to make sure you completely understand all the steps shown here. Let's try an example. 1 minus 3x minus x less than or equal to 21. The first step is to combine the like terms, and we get 1 minus 4x less than or equal to 21. Then we subtract 1 from both sides, leaving -4x less than or equal to 20. We divide by -4, and so this requires us to flip the operator. So the answer is x is greater than or equal to -5. On the number line, there's a closed circle on -5 with the arrow pointing to the right. Let's try another. 7 parentheses 1 plus 6x is less than 7 minus 4x. First, we distribute the 7, getting 7 plus 42x less than 7 minus 4x. Then we combine two steps by first adding 4x to gather the variable terms on the left, and then minus 7 to gather the constant values on the right, and we end up with 46x less than 0. Divide by 46, and we get x is less than 0. The operator stays the same since we divided by a positive value. On the number line, open circle on 0, arrow going to the left. Here is another. 3x plus 11 less than or equal to negative parentheses 3x plus 7. First, we distribute the negative, and remember this is an implied -1. So we get 3x plus 11 less than or equal to -3x minus 7. We combine two steps in one, adding 3x to both sides to get the variables on the left, and then minus 11 to get the constant values on the right, and we get 6x less than or equal to -18. We divide by 6. The answer is x is less than or equal to -3. The operator stays the same since we just divided by a positive. On the number line, closed circle on -3, arrow going to the left. Here is one that requires even more steps. First, we distribute the 3, and we get -6n plus 27 is less than 6n plus 9 minus 3n. Then we combine the like terms on the right, and we get -6n plus 27 less than 3n plus 9. And now we do two inverse steps in one, subtracting 3n from both sides to get the variables on the left, subtracting 27 to get the constant values on the right, and we get -9n less than -18. We divide both sides by -9, flip the operator, and we get n is greater than +2. On the number line, you have an open circle on 2, arrow to the right. Let's do one more example. 2 minus 3r plus 7 parentheses 3 minus 5r greater than 137. First, we distribute the 7, and we get 2 minus 3r plus 21 minus 35r greater than 137. On the left, we combine like terms. 2 plus 21 is 23. -3r minus 35r is -38r. And our resulting inequality is 23 minus 38r is greater than 137. Then we subtract 23 to get the constants on the right, the variables already on the left, and we get -38r greater than 114. Divide both sides by negative 38, flip the operator, r is less than negative 3. On the number line, open circle on negative 3, arrow to the left.